Black holes, they're like massive puzzles in the huge cosmic playground, really getting scientists and space enthusiasts scratching their heads. Imagine a place where gravity is king of the castle, so strong that nothing can escape its grip. That's the world of black holes, where the rules of physics get thrown out the window. Even light, the fastest thing out there, can't outrun a black hole's pull. This creates a patch of darkness, like a hole in the fabric of space. These celestial objects are like dents in space-time, where gravity's pull is so strong, it bends the very fabric of the cosmos. This massive force bends light and messes with time, creating a truly bizarre landscape. Black holes come in different sizes, each with its own quirks and origin stories. Stellar black holes, born from the dramatic deaths of massive stars, are the most common type. These cosmic powerhouses form when a star runs out of fuel and goes out with a massive bang known as a supernova. These black holes can be several times heavier than our sun, but they're incredibly compact, squeezing into a space just a few kilometers wide. Hiding in the centers of galaxies are supermassive black holes, millions or even billions of times heavier than our sun. These giants are the engines driving the action in their host galaxies. These gravitational heavyweights have a huge influence on their galactic neighborhoods, shaping how stars and planetary systems form and evolve. The idea of black holes comes from Einstein's theory of general relativity, which describes gravity as a curvature of space-time caused by massive objects. This groundbreaking theory totally changed our understanding of the universe. When a massive star runs out of fuel, its core collapses under its own weight. This collapse is so intense that it creates a singularity, a point where density goes through the roof. This singularity sits at the heart of a black hole, a mysterious point where the laws of physics as we know them go haywire. Surrounding the singularity is the event horizon, an invisible line in the sand beyond which nothing can return. Cross this line, and you're not coming back. Once something crosses the event horizon, it's trapped forever in the black hole's gravitational clutches, lost to the outside universe. Even light can't escape, making black holes invisible to our telescopes. But we can still figure out they're there by watching how they affect nearby matter and light. As matter spirals into a black hole, it forms an accretion disk, heating up and emitting high-energy radiation. These emissions give us clues about the nature and behavior of black holes. Some black holes even shoot out powerful jets of particles at nearly the speed of light, showing off the immense energy released in these extreme environments. As we continue to study black holes, we're learning more about their secrets and the fundamental nature of our universe. The quest to understand these cosmic enigmas is far from over. Stellar black holes are born when massive stars, at least 3 times heavier than our sun, run out of their nuclear fuel. These colossal stars, often found in the busiest parts of the galaxy, go through a dramatic makeover as they reach the end of their lives. Stars are like giant cosmic furnaces, fusing hydrogen into helium in their cores and releasing enormous amounts of energy that fight against the constant pull of gravity. This fusion process is the heart and soul of a star's existence, giving off the light and heat we see from Earth. This delicate dance between outward pressure and inward gravity is what keeps a star going. It's a constant battle, with gravity trying to crush the star, and the pressure from nuclear fusion pushing outwards. But this balancing act can't last forever. As the star gets older, the nuclear reactions in its core change, messing with this delicate equilibrium. As a massive star ages, it gobbles up its nuclear fuel faster and faster. The core shrinks and heats up, making the star burn through its fuel even quicker and speeding up its demise. Eventually, the outward pressure from nuclear fusion can't hold back the inward crush of gravity any longer. The core's temperature and pressure become so extreme that the fusion process can't keep up. The star's core collapses in the blink of an eye, triggering a mind-blowing explosion called a supernova. This explosion is one of the most powerful events in the universe, outshining entire galaxies for a short time. The supernova blasts the star's outer layers into space, scattering heavy elements throughout the cosmos. These elements are the building blocks of planets, moons, and even life itself. Meanwhile, the core keeps collapsing relentlessly, crushing itself into a singularity, a point of unimaginable density. This singularity is the heart of the black hole, where the laws of physics as we know them go out the window. The singularity is surrounded by the event horizon, the point of no return. Once anything crosses this boundary, it can't escape the black hole's gravitational pull. While stellar black holes are incredibly dense and have a powerful gravitational pull, they don't act like cosmic vacuum cleaners, randomly sucking up everything in sight. They're more like cosmic traps waiting for something to get too close. Their gravitational influence, while strong, is only effective in their immediate surroundings. This means only objects nearby are affected by their immense gravity. Only objects that stray too close to the event horizon risk getting caught in the black hole's gravitational grip. This boundary marks the edge of the black hole's influence, beyond which nothing can escape. The universe is a massive place, chock full of billions upon billions of stars, and a whole bunch of black holes we haven't even discovered yet. Given all that space, you might be wondering if a black hole could bump into our sun. Luckily for us, the chances of that happening are slim to none. Space is mostly empty, and the distances between stars are absolutely massive. Even if a rogue black hole decided to swing by our solar system, the chances of it actually hitting our sun are astronomically small. It'd be like winning the cosmic lottery, but with some seriously bad consequences. But don't worry, if a rogue black hole did decide to pay us a visit, astronomers would probably spot it long before it became a threat. Black holes have a strong gravitational pull on their surroundings, causing a bit of a ruckus in the orbits of nearby stars and planets. Astronomers are always keeping an eye on the movements of celestial objects, and any weird gravitational anomalies would set off alarm bells. While the odds of a black hole colliding with our sun are basically zero, thinking about these hypothetical scenarios lets scientists push the boundaries of physics and imagine what might happen during extreme cosmic events. Let's imagine the unimaginable, a scenario that throws everything we know about the cosmos out the window. Picture this, a rogue black hole way smaller than our sun, but with an incredible gravitational pull, is on a collision course with our star. This cosmic dance of destruction is both mesmerizing and terrifying. As the black hole gets closer, its immense gravitational pull starts to warp the fabric of space-time around it. The invisible threads of gravity begin to weave a complex and distorted tapestry. The sun, caught in this gravitational web, begins to distort and stretch. Its once perfect spherical shape starts to elongate, pulled by the relentless force of the black hole. This distortion happens because the gravitational pull isn't the same across the sun's diameter. The gravitational forces at play are uneven, creating a cosmic tug-of-war with the sun's structure. The side of the sun closer to the black hole feels a much stronger gravitational force compared to the side farther away. This imbalance in gravitational pull has a dramatic effect on the sun's stability. This difference in gravitational pull stretches the sun, making it look like a giant, elongated teardrop. The sun's outer layers are drawn towards the black hole, forming a bridge of stellar material. As the black hole gets closer, it starts to siphon off material from the sun's outer layers. This process, called accretion, strips the sun of its outermost gases. This material, heated to millions of degrees, spirals inward, forming a swirling disk of gas and dust called an accretion disk. The intense heat and friction within the disk make it glow brightly. The accretion disk emits intense radiation across the electromagnetic spectrum, shining brightly as it feeds the black hole. This radiation is like a beacon, signaling the black hole's insatiable appetite. Slowly but surely, the sun shrinks in size, its outer layers consumed by the black hole. The once mighty star is reduced to a shadow of its former self. The sun's core, exposed and radiating intensely, continues to fuel the black hole's growth. The core's energy is the final offering to the black hole's insatiable hunger. The accretion disk, a beacon of light and energy, stands as a reminder of the ongoing cosmic feast. This luminous ring is a stark reminder of the black hole's destructive power and the sun's ultimate fate. If a black hole ever ate our sun, it would be a very bad day for everyone on Earth. As the sun's outer layers get peeled away, the amount of sunlight reaching our planet would drop dramatically. Earth would be plunged into a never-ending twilight, and temperatures would plummet, leading to a worldwide freeze. Photosynthesis, the way plants turn sunlight into energy, would come to a grinding halt. No sunlight means plants would wither and die, causing food chains to collapse and countless species to go extinct. The oceans would freeze over, trapping the once thriving life within their depths. The black hole's gravitational pull would reach beyond the sun, messing up the delicate balance of our solar system. Planets, once held in their orbits by the sun's gravity, would be thrown into total disarray. Some planets might even be kicked out of the solar system, flung into the vast emptiness of interstellar space. Others might smash into each other in a catastrophic game of cosmic billiards. Our once orderly solar system would descend into chaos. While the idea of a black hole gobbling up our sun is a popular one in sci-fi movies, it's important to remember that it's super unlikely to happen. However, astronomers have seen similar cosmic events happening in faraway galaxies, giving us a glimpse into the violent processes that shape the universe. One such event is called a tidal disruption event. This happens when a star gets too close to a supermassive black hole hanging out at the center of a galaxy. The black hole's massive gravity rips the star apart in a process called spaghettification. The shredded remains of the star form an accretion disk around the black hole, releasing a bright burst of radiation that astronomers can detect across vast cosmic distances. By studying these tidal disruption events, astronomers can learn more about the characteristics of black holes, how accretion disks work, and the extreme environments surrounding these mysterious objects. These observations give us valuable data that helps us better understand gravity and how the universe evolves.